Okay. So, let us go to the remote monitoring. So, this part will be, I will not talk about much sensor, but I will talk about general problem, and main emphasis will be the air and water. Okay. So, when we talk about the environmental monitoring, always the question comes that why do we need to monitor? So, we will look into that, and we will give some applications and then climate issues. Now, one of the most important things is that we need to know what are the parameters we need to monitor and how can we monitor them. So, that is why the sensor comes into picture. But it is a area of multidisciplinary, and at the end of the day, the funny thing is that we the engineers, we can come out with a solution, but that solution may not be used because at the end of the politicians, they dictate everything, isn't it? So, that is the funny thing, and sometimes you see that it does not happen because either the cost issue or other issue or many other things. So, it is the cross disciplinary area, multidisciplinary area where the engineering things goes to administrative part, and the administrative part they think that is not required. Now, it was realized by IEEE. So, effectively I got some money to develop this course. It is not that we are coming here only for the GIAN course, but it was 2 years back IEEE asked me to develop this course. So, we got something from IEEE, and the topic is remote monitoring. What sensor and instrumentation required for the remote monitoring. So, monitoring parameters remotely. Effectively, when we talk about the monitoring, we always think that pollution, isn't it? We always think of the pollution, and two important things for our survival is water and air. Without water and without air, our life cannot exist, isn't it? So, we need to know what actually pollutes them and how can we monitor them. So, water and air. So, water pollution, what do you mean by water pollution? So, if I ask you that, can you define what is water pollution? So, you may actually say that chemically or physically or whatever way you can say the water is like that. I want pH should be 6.8, okay, like that, physical parameters will be like this. So, anything which actually mixed with the water, it can be any kind of physical things, any kind of chemical things mixed with the water, changes the water properties. That is actually water pollution. Pollution does not always mean that it will harm. Of course, we think that way, that polluted means it will harm, but sometimes it can make good, isn't it? But whatever it is, when you mix something to water, water changes its properties, that is the water pollution. So, here what we can see here, when like in New Zealand, we extract oil under the sea, how can you ensure that oil will not leak, isn't it? So, in statistically it has been seen that 5% oil which is extracted is actually leaked into sea. So, anything which actually mixed with the water, that makes the polluted, and organism, not only the human but whole animal kingdom, we rely on water. So, it can do harm. So, that is the, so now if you see how we can make the water polluted, pathogen, any kind of bacteria, okay, when it mixed with the water. So, I actually salute Mr. Modi. Is not that I have come for promoting BJP or Congress, but if you see everybody has got toilet. I remember 18 years of my life did in the open air, unfortunate. So, if everybody has got toilet, we could save lots of bacteria not getting mixed with water. You understand? So, it is a huge source of making the water polluted. Organic matters. Even I tell my childhood, when a when an animal like a cow or something died, we just go and throw. Some people come to eat that dead animal, but lots of parts remain. And then rain comes, this thing that comes, where does it go? Ultimately it goes and mixes with the water, isn't it? If you think of during big storm or flood, lots of animals, lots of plants, they actually mixed with the water. It doesn't matter that it only happened in India, it happened in any parts of the world. Especially when you have got natural calamities, it can happen in any parts of the world. Ultimately, you have got connected with either Indian Ocean or Atlantic Ocean or Pacific Ocean, isn't it? Tsunami happened in Japan, and after 3 months, Japanese car came out in the California coast. They are separated by 11,000 kilometers. You understand? So that's the situation. You have to think of that way, that whatever we do harm, actually you are harming for other people in the world. It's not restricted only your part. So this is a big problem. So organic chemicals, pesticide, fertilizer, plastic, detergent, gas and oil, whatever you mix. Like in New Zealand, as I said, we use very less fertilizer, but still we use fertilizer. It's not that we don't use. We use pesticides. Whatever is not used, unused, that mix and finally it goes to water. So you pollute the water in many different ways. Inorganic chemicals, acids, salts, toxic metals, whatever it is, and then toxic wastes. So whatever is left over is go. So this is the big problem, water gets polluted. And it's very difficult to say that you can stop from pollution. It's very difficult and impossible to achieve. Not only that, you also have the physical agents. Sometimes some soils, solids mixed, especially when you have got the floods. It brings lots of things and mixed with the water. Radioactive waste. I mean, we always know that we do not want the nuclear power station close to the locality, isn't it? Because you have the radioactive waste, it can come and mix. So always we like that should be very far. So it gets with the water. Now water pollution we define in two different ways. One is called point pollution and another will be called multi-point. Now point pollution is one of the easiest thing to know with the help of sensor. So you are actually allowing all the pollutants to mix with the water at some specific point. So for example, if you think of a company, they discharge a lot of things to water. Okay? Now you can install some sensor and you can find out what are the pollutants they are mixing, and you can take some corrective actions. Of course, the government and the power who are in the they need to have the will to do the things good for the human being, but it is possible. So what is the minimum point? You have the pollutions at one point. So you can think of septic tank system, storage lagoons for polluted waste. Like in New Zealand, we have a specific area where all the waste are dumped, and they are made in such a way that it will not mix with other things. But if you think of someday huge amount of water, huge amount of rain, you understand? So that type of things can happen. Municipal landfills and wastewater treatment plants. So those are the example where the possibility of making the water polluted through a single point. And it is very easy to monitor using sensor if you want to do that. And in many places it can be. Like I was involved with a project in New Zealand many years back, and this is a company where they make corn. Okay, the corn. So the corn, New Zealand produces a lot of corns, and the corn made into different products. But the waste comes from that plant. It's a huge amount of waste, but usually in New Zealand you cannot do anything. So we were involved to do some kind of treatment from the west, how we can do, but that was like a magnetic field kind of things, okay, but it was not a success because magnetic field does not help for non-magnetic material, but it was happened. You cannot just dump somewhere. Company has to take the responsibility because they make money, they can add some money for making that thing happen so that they add only the good things to water or environment. But you can understand that if you want to implement in India, it will take some time. But it is possible. It's not that it is impossible. It is possible. If everybody become conscious, every human being become conscious about his health, about others' health, about the health of the country. I mean, I'm telling you that I got the feeling that I can say proudly as I am Indian only when I went to Japan at my age of 30. Before that, we did not, because we grew up in a communist way. Okay, I'm from West Bengal, as you know, so they don't love India, they love other country. So we grew up that way. Only when first time I went to Japan, I made the Japanese friends. They always say, I am Japanese. Okay, in Japanese called Watashi wa Nihonjin desu. That means I am Japanese. You talk to him, oh, I am Japanese. So in the first, you will not understand. Then I'll tell, what's so special about it? You are Japanese, yes. But when you mix with them few weeks, few months, then you realize that actually they have that feeling, in their heart, and they always feel very much proud. And that's what if you take a chocolate and put the cover somewhere, you can see they take it out and put it into the dustbin. So that's their character. That time I feel that why don't I say I am Indian? Because that part is missing, isn't it? That part was missing. We never think that we love our country. We always try to criticize others without doing any good. Okay, sorry, I did not come here to give political lecture. Then they will not allow me to go back. I want to go back. But that's the way things are. So you need to change. So actually, I was telling my brother-in-law, who is a school teacher, that introduce that thing to the students, that don't spit. Okay? When I go to Calcutta, go to my home, which is 45 kilometers, I always see everybody is spitting, this thing, that thing, do urinate, and I feel, very, very yucky. I don't feel to do handshaking with people because I know little while ago he has gone and urinated, did not wash his hand. It's very unfortunate. But if you ask yourself, is it so hard? I did not spit for last 25 years. Before that I used to spit a lot. If Indians go outside, they become such a nice people, why they cannot do here? It's not something impossible. It's very, very possible. But we just don't do. So if you tell that today's the young kids, who is born after 50 years, India will be the top. But it takes some time. So that's why when Narendra Modi, the Prime Minister, taking Swachh Bharat Abhijan, being outside, we feel so happy that yes, at least one man is telling that we can be clean. So support him as much as possible without thinking of the political lines, because that is important for India. That is not important for BJP, Congress or UP. That is important for Mother India, and that's required. And that's what when I come every year, one time, two time, I try to tell, why I am actually outside and I feel those things are good and we should be here. So that's required, that we need to do that. And that's not impossible, that's not difficult. It's just the mentality. That's changing the mentality. And if we do, actually the pollution problem could be solved a lot of ways. If you think of that whatever we eat and waste we throw, instead of throwing, putting like in my pocket. I was having some chewing gum. I kept it in my pocket. Okay. When I go to guest house, I'll put it in the dustbin. So it can come. It's not that it's impossible. It's not very difficult. It's just the mentality. So actually, this is the pollution problem. A lot of things come from man-made, okay, human-made. That can be under control. You do not need sensor. Think that sensor does not do anything. At the end of the day, sensor gives you data to tell you the level of pollution. But sensor cannot control. You need to control by some other ways. So if you do not do that, what is the purpose of the sensor? You understand? Sensor and monitoring you do not actually need if you do not have the intention to change, because at the end you need to change it, and in order to change it you have to have some way of doing that, because sensor is very important. As Lord Kelvin told, that you cannot improve anything unless you know. You understand? To know that you need measurement, you need sensor, but in order to control, it's not depends on the sensor. It depends on the mentality, depends on the system, depends on the surrounding environment. So that's very important, that how can we control the pollution? We can control if we want to control. So you have, but if it is a non-point pollution, which is very difficult to control, because non-point pollution actually basically coming from the natural calamity. Think of that, you have got huge amount of rain, like the way it happened in Chennai in December, January, because I was thinking of coming, I had to postpone my trip for a few months. If you have huge amount of rain and our system is full of other things, so there is not enough passage of water, water will be outside, so it makes everything together, and that's what happens. So under that conditions it's impossible. So most of the non-point pollution is basically coming due to natural calamity, where you cannot do anything. So here as you see the farm, too much water, they all together, storm, sometimes you have huge construction, think of that a dam is happening somewhere, or even like a road is happening, no? So it's a huge amount of area, so then it is becoming non-point pollution. In some country, especially like in Canada, also like Alaska, where there are too much snowfall, okay, in also Europe, parts of Europe, too much snowfall, then the roads become very slippery and it becomes dangerous for driving. So what they do, they apply salt, okay, they apply salt, so it becomes less sticky. Also they use different types of tire, and the tire has got chains, but still when you apply something on the road, that mix up, isn't it? So that type of things also make pollution, and then fertilizer applied to crops, and so it's a huge area where you cannot control. So few of the things you cannot do anything, but point control is always under control. Next type of pollution is the air pollution. So one of the thing is the thermal. So thermal pollution, as you can see that in the power plant, where you give water, steam or heat to water, so it becomes steam. Along with that, lot of dust particle, lot of dirt particle, they mix up, and then it goes to the air. So that is one way of having this pollution, thermal pollution. And then this bioaccumulation, so which I was talking, so if the water gets polluted, you have that blue algae and other types of algae, other types of grass, they grow. So that always a indication of water gets polluted. So you can measure, if you have sensor, you can measure the level. So algae, and then it's eaten by shrimp or other animal, fish. Now it can go, instead of seal or bear, it can go to human. So we can consume. So that type of situation you can monitor, that how you don't need to see that whether algae is grown, isn't it? Because algae grown is a later stage. Before that, water has already polluted. The time of pollution to the algae growth maybe few weeks. So you do not need to wait that long. So you can actually monitor that and take corrective actions if you want to do. So algae is one of the indications of water quality. And the next topic is coming, ocean pollutions. Usually like pond, river, lake, they are within the country. So they are polluted by the inhabitants of those countries. But if you think of ocean, which is like, of course, we have only 3-4 oceans, which is not under the control of any specific country. So there is a law that if the distance is 22 kilometer, okay, so if you see the coastal lines from there to 22 kilometers, that is under the jurisdiction of the country. Okay. So India can think of any 22 kilometers, any coastal lines, that is under India. Nobody can do anything there. So that's why always like fishermen, no, Indian fishermen are caught by Sri Lankan Navy or no Pakistani, because if you extend that part, then you are not under your country. So 22 kilometers. But there is the economic zone which is actually 370 kilometers. So from the coastal line to 370 kilometers, you can do any activities, economic activities, still allowed. But after that, it's nobody's land, and that's the big problem. So if you think that I can do any pollution after 370 kilometers, you are allowed to do. You understand? That's the biggest problem. And sometimes you have, I don't know whether you see, because we are in New Zealand, we always have this problem. Japanese people, they like to eat whale, okay, and they kill lot of whale, and they say that they are doing research. And in New Zealand, whale watching is one of the most important tourist attraction. You understand? So in New Zealand, we always get very angry and irritated when Japanese people say that they are killing whale for research, because we know they eat, and whale is one of the very delicious food, I mean delicacy, okay, is very costly amount of if you go to eat whale, but they do. So this is a big problem, and this is coming because of that if you actually catch the whale after 370 kilometers far from New Zealand to Japan is 5,700 kilometers. You can understand. We cannot do anything. So last year, one group went to protest, and Japan put them into jail. Okay. Then it took quite a lot of time for the New Zealand Prime Minister to do under the table and to make them free. But that's what happened. So this is one of the problem, that after 370 kilometers, it's nobody's land. If you have power, you do, isn't it? This is the big problem. So who will take care of that? Now, as I told that whether you take care or not, you can be affected after a few more years or few more months, because it will not stay there, isn't it? So this is the problem. So pollution of ocean, it can happen, most of the time it comes something from the land, and it's very, very difficult to monitor. You can monitor only at few places installing sensor, but how can you monitor all the areas, because land area is a huge. So 85% comes from the land. Then many people, those who go either by boat for shipping or something, for fishing or something else, they can dump lots of things also from the ship. Big ships, they goes either carrying people or for tourists or taking the things, because if you send something very heavy, if you do not pay a lot of money, usually you go by ship, isn't it? It takes time, but it's cheaper. So they always dump lots of things, and then oil leaks. And funny thing is, you will find that at the end of the day, they penalize by money. If you remember a few years back, British Petroleum BP had an accident in US coast, and finally it managed by money. They gave US government few tens of billions of dollars, but money actually cannot do anything, isn't it? Even in New Zealand few years back, one big ship was coming, and then just before entering the shore, it's I think 10 kilometers accident, and it tilted in such a way they could not do anything. So it was a luggage, I mean the goods all just went to water. So that type of accident, that type of things happen, and you get the pollution. And then the oil, 5% of the oil which we extract, that can leak. So these are the all different sources of pollution. Next important element which actually makes the things or makes our life quite polluted is the plastic. Now I actually feel a lot of pain, because when I was small in West Bengal, my 3 uncles were working in the jute industry, okay, and jute was very, very popular in West Bengal. They all gone, but I think it's a wheel, it will come back again, because now people realize that plastic is doing more harm than good. You cannot destroy the plastic, you understand. So that's the biggest problem. In New Zealand now we did not make a rule yet. The shopping center, they actually have jute bag and different other bags, not plastic. They encourage customer use that bag, and they are telling that another few years time they will stop, because right now they still use plastic bags, but they are encouraging. The plastic is a big problem. So they are, because the problem is that you cannot dispose. So whatever you have, it will come in some ways. So in US, only in one day they collected 300 tons of plastic waste from the US coastlines. So you can understand how much is getting mixed with the. So this is the plastic you see in normal situation. No? And then the air pollution. Another air pollution coming from the different gas which is burned and going to the air. Also some natural things like volcanic eruption, they also can add many things. So air pollution is becoming big issue. And if you see the source, there can be many sources. It's impossible to develop a particular sensor for determining all the different parameters. You cannot. You may have a sensor array for few different things, but it is not possible to have one sensor to tell you. So this you have heard in recent times PM. So this is the PM particulate material. So the particulate material, it can be any dirt, it can be dust, basically some kind of hydrocarbons which are not completely burned and they mixed with the air. You will be quite surprised. I visited last month, January, China. Again in December I went to China. Whenever I was talking to anyone, I mean not only student, they say here PM 2.5 is too much. You understand? They say PM 2.5 is too much. So particulate material is bigger problem now because it can do a lot of harm to human. Lead is one of the constituent of the pollution for air, nitrogen oxides, carbon monoxide, volatile compounds, sulfur dioxide. So there are many compounds which actually pollutes the air. So you may say that what is actually PM 2.5? So I just gave you comparisons. If you see our hair, if you take the diameter of the hair, it's around 60 micrometer. Of course, somebody might have little bit thicker, okay, but usually it's 60 micrometer, average thickness of hair. With that particular material is the diameter. If it is 2.5 micrometer, that is qualified as PM 2.5. There is also PM 10, where is the diameter is 10 micrometer. So you can understand that sometimes if you have hair, you may not be able to see your naked eye. So those particular material is impossible to see with your eye. And we can breathe, they can all go to our lungs and it can create a lot of problem. Now how do you actually design sensor for that? This type of material you cannot do anything with the sensor. What it does, you have to do is the under microscope. So if you collect some samples, you can see under the microscope and then you can find out whether they are of that size. So in my university, one of my colleague, he is doing on image processing and his research area is the pollen. So pollen usually come from the plants. So the flower and the fruits of different plants. When they become very ripe or this thing light and the wind comes, they take them. In fact, that creates a lot of problem. Like for me, I am living now 16 years. I did not have any problem 11 years. But now during the summer time, I do a lot of sneezing and I rub my eyes too much because the pollen that actually infects. In my home, me and my daughter suddenly becoming that problem. So it can affect human because you don't know, you cannot see and you just breathe. So this particular material that can be very, very harmful, ultimately it go and stuck with our lungs and create a lot of problem. So it comes from the diameter of the material. Actually, air pollution is not that harmful to human if you allow the air to circulate. Okay? That's why it's not so much. But what happens if you have a layer above the maybe some 100 meters, 200 meters above the earth's surface, and if that layer is used as an insulation, then you are a big problem. And that's why in many Indian cities, like New Delhi is one of the famous city, you have this problem because they form a layer where the air cannot carry the dust particle, they are stuck. Not only New Delhi, in many other cities like Los Angeles, they are also famous for that. But of course, in America that much pollution is not there, so that's why it is not that big problem, but it can happen. So that type of problem called thermal inversion. So you have this type of, so you will find that it's smoggy because that layer does not allow the hot air to carry the dust particle. So it's sandwiched between that. So it's basically the smoke and fog, that's called smog. Okay? So the smog is basically smoke along with the fog. So usually when the air becomes hot, the air goes to up, and while it goes up, it carries the particle. But if you do not allow it to go, then you have this problem. Now in another thing is the called stratospheric ozone layer. Ozone is very important. When it comes to the ground level, it can do harm. Okay? But if it is above the earth's surface, it's very, very useful. Because in New Zealand, you will be surprised, in New Zealand, we have the highest rate of skin cancer. You will be surprised, highest rate of skin cancer. And this skin cancer comes because of ultraviolet radiation. In New Zealand, we do not have ozone layer. Ozone layer is empty. Okay? So there is a hole on top of New Zealand, no ozone layer. So if you have, as you can see, if you have 1% decrease in ozone, it allows 2% increase of ultraviolet radiation. So whenever we have in the summertime, like my son goes to outside, we always apply cream to protect from UV radiation. Okay? So it's a very, very dangerous thing. New Zealand has the highest amount of skin cancer because of that problem. So it's very good when it's the upper layer, but when it's down, then it's a harmful thing. So we can have sensor for that. And then of course the pollutant level, sometimes you have the primary pollutant which itself can make the pollution. Sometimes primary pollutant react with the primary pollutant, some chemical reaction takes place, then you have the pollution, then it is called secondary pollution. Now some of the ways, as I said, that we can monitor, but in order to reduce, there should be some control. So some of the ways we can do, one of the thing is, how can you reduce the pollution coming out of automobile? Okay? Of course, there are many other things, automobile. So here one picture as we are showing that share. Okay? I mean, if you share, but interesting thing is, there was a survey in America. American people, like in New Zealand, people travel not that much long, but American people travel quite long for office. And they like to travel. So they start maybe 7 o'clock, drive 1 hour to reach to office. So, there was a survey, and the question was, would you like to go sharing with your friend? And you will be surprised, almost 85% told no. 85% told no, that they want to go by their own car. Why? Because they told that out of 24 hours, that's the time I get for myself. Isn't it? You will be surprised. Because when I go to office, I am not within myself. I have to deal with my colleagues. I come home, I have to deal with my family. Then of course I sleep. That's the time I get for myself. So I want to drive. So in America, you will be surprised, there is a road called carpool. In India, we don't have that. Carpool. Like if you go to Los Angeles airport and then go to the Los Angeles city or Pasadena where Caltech is, you will have a road called carpool. Carpool means you must have 2 or more people in the car. Then you can use the lane. Okay? So you can go quickly because other lanes are crowded. So that type of things America has done to reduce the pollution level. Of course, here we can do, if we develop the electric vehicle. Lot of research is going on for electric vehicle, but still you don't get more than 200 kilometer from a fully charged battery, isn't it? So sometimes if you don't want to be in trouble, you don't use electric vehicle because you don't. But I was quite excited to see. I was in France last year. They have that smart car, which kind of nano car. They are all electric vehicle. So when they come to the city, they have a parking place, which is basically a charger. So you actually borrow or hire that place for your park, and that's basically a charging station. So you go to office 8 hours and your car is getting charged so that you are safe to go back your home. So that type of things, electric vehicle can reduce the pollution a significant amount. So if you see in a few statistics, it's a huge amount of pollution happening. Of course, this is all for America, and that can actually end up with the human, isn't it? So yesterday I was talking with Professor Islam that in New Delhi, the current generation may not be feeling that because this result does not come tomorrow. It will come after 10, 15 years. When we will be able to detect that, it will be too late. Okay? So unless we do something, it will be very difficult. So there will be different types of problems. Okay? And so I am not going to detail these things because those are the effects. So we need to know, and that's why sensor is very important. But as I said, sensor can give only the level of pollution. If you want to control, if you want to do anything corrective actions, that has to be done based on the data from the sensor. So what are the things we can monitor? So what are the sensor we can use? So we can actually have different types of sensor to monitor the parameters from the environment, and those data will be useful for taking some corrective action. So temperature, humidity, light intensity, wind, those are the normal things. Then we have to have soil for agricultural applications. We need to know the moisture, we need to know the salinity. Also, there are nutrients like nitrogen, phosphorus, potassium. So one of my students is developing a sensor array for these 3 things, nitrogen, potassium and phosphorus. So they are useful, how much fertilizer you want to spray, want to give. And then water contaminations, which is a open-ended problem. You don't know how many you can do, so you can go for specific parameters. And then in air also you can go for oxygen level and other gases, nitrogen, carbon monoxide, carbon dioxide, and other dangerous gas like methane. And so you can get any amount of sensor, and then you have to use that particular sensor for particular parameters. Now, when you go for the sensor, you also follow some standard. So, there are few standards which are available. So, like we use wireless sensor network, we have standard IEEE 802. So, if you go for ZigBee, IEEE 802.15.4. So, you have to follow a certain standard. Now, these standards are useful if you think of making your sensing system interoperable, so that you develop something. If your friend also follow the same standard, then your development can be straight away used by him, and vice versa. But if you do not follow the standard, then you cannot do that. So, that is why, I mean, we talk about the smart sensor. What we want, a smart sensor is like a USB memory stick. You understand? USB memory stick, I brought something from New Zealand, I am using here. It can be used without any problem. So, the smart sensor will be something like that. If you develop something here, you can use it straight away in other country, because you follow the same standard. So, you need to follow the certain standard, but if you see, there are many standards. So, you may always ask which one. You do not need to bother about which one, but follow a certain standard. And if somebody also follow that standard, you are interoperable. So, there are many standards available, and especially IEEE 1451, that is called the smart standard, smart transducer, but it is too much software dependent. So, because of that, it is not very popular yet. Okay. So, IEEE standard which are 802, they are still very, very famous, which is for Bluetooth, ZigBee, Wi-Fi, okay, also WiMAX. So, when you think of choosing some sensor, you have to think of the performance aspect. So, there are a lot of parameters: accuracy, resolution, lifespan. Lifespan is very, very important. I was talking with someone, for the Islam student, for the structural health monitoring. The biggest problem of the structural health monitoring is the lifespan. Lifespan of a structure may be 40 to 50 years, lifespan of a sensor is 4 to 5 years. Now, who will monitor whom? You see the practical problem. So, that is the biggest problem, that if you do not have a huge lifespan. So, interesting thing is, a few years back I was in Taiwan and I was talking with a company, and I was telling IoT, and we can make IoT for long life. He stopped me. No, I could not understand. So, he told, if you make sensor for long life, my company will be stopped. So, you cannot make like that. Make for 3 to 4 years. So, you can understand the problem. So, sometimes that type of parameters can decide. So, if you have a structure for 40 years and you have a sensor for 3 to 4 years, you have to replace the sensor many times. So, it's a problem. But anyway, so that is a big problem, especially for the wireless sensor network. Lifespan actually dictated by not by the sensor, but by the battery. Okay. So, when we talk about the extending the lifespan, is how do you extend the life of the battery. Okay. So, battery is providing the power, energy. How can you actually use very less energy? So, comes from that. Drift, ease of installation is very, very important. I mean, sometimes we do research in the lab, we doesn't actually think of how it will go outside the lab. How do we install? What are the parameters we need to consider? So, we do something thinking something else, but actual scenario is completely different. So, installation is very, very important. Ease of use. Sometimes you will see the students, they like to use some kind of microcontroller board. Other board they don't, because that is the ease of use. How can you quickly pick up the things, isn't it? So, there are many platforms available. Some are very popular compared to others. So, then the power consumption, how can you make the electronics so that power consumption is very less? Size, how can you make it small? Cost, how can you make it less? How can you make it flexible? Flexibility can be like sometime extension. So you may have 3 sensors interfaced with your system and you decided to use extra one. Is your system flexible to give the provision of adding something extra? So how can you make the system flexible? Replacement option. Replacement option is very important for smart sensor. So think of your sensing system, you have used some temperature sensor and then you realize that your temperature sensor is not working and you wanted to get the sensor from the same company. By the time company closed down. So what can you do? Can you get a sensor from a different company and without changing much of your circuit, can you connect it to your system? So replacement is very important. How can you do it very easily? Analog digital sensor, sometimes if you are flexible enough to go for digital, all digital, life is really comfortable. But it never happens, isn't it? Because if you see temperature sensor, you never get digital, because it's always analog. Of course, you can have a A to D converter, you get the digital data, but in reality, you always get analog signal. So that type of problem. Interfacing issues, ability to reprogram sensor for different operation scenarios. Software is very important, because without software, system is not complete. So you have to give a lot of importance on the software. And then future extension. Many times we actually ignore uncertainty of measurement, isn't it? I mean, we always think that sensor gives perfect reading, isn't it? But 2 important things happen. One is the degradation. We call ourselves, we are aging, isn't it? There is nothing hard for the sensor to get aged. So how do you actually ensure that sensor does not degrade? Or sensor degrade, but your performance coming out of the sensor is taken care. And the uncertainty of measurement. Sometimes if you go for one sensor, you get the data, okay, for this room, maybe now 21 or 22, because if you have a sensor and it gives you 25 or maybe 35, you may have a feeling that the sensor is wrong. But when you have the system, you cannot do that, isn't it? So sometimes you may say that I don't rely on one sensor, I go for 2, but now the 2 behaves erratically. What do? You take the average. So sometimes you have to go for redundancy. That okay, I go for 3 sensors and take 2 of them who are close to each other. And if you do that, you are actually adding the cost of the system. So there is always, like you know, the Boeing or Air 380, they have 4 engines. Only 1 engine operate at the one time, but other engine one of standby, because if something goes wrong, that engine will come up. But that's related to human, because carrying 500 people, you cannot take the risk. But if you think of your distributed measurement and you have thousands of sensors and you put 3-4 sensors for one measurement, it will not be cost effective. So it comes down that how do you actually make your system? So those are the issues we need to think. So when you think of the electronics, first important thing is the power supply. Without power, without energy, nothing works. So you have to have the power supply. So what type of battery you will use? And battery cannot give you continuation of energy for long. So you have to think of energy harvesting. One of the common thing is used is the solar, because solar is kind of established. Still, I mean the size of the solar panel, manufacturer, efficiency, all these things are still going on, but still solar is lot of time you can rely. But that's not the only thing. If you think of somewhere where you do not have sunlight for few days continuously, solar may not be the option. So other things like from wind, but wind is of course is established for the big power, not for the sensor network, because you usually need the wind energy to be installed at high elevated place, not like low ground. The stream and tidal is also considered depending on the applications. RF, we always say that RF is everywhere, we can always extract from energy from RF. Some people are telling the vibration, especially the structural health monitoring, they are telling that we can extract energy from vibration, especially for like railway lines or the bridge, those type of applications. And also some people are telling, can we actually use the rotation of the earth? Okay. But all these techniques, what is happening at the moment, you get power of the order of few hundreds nanowatt to few hundreds microwatt. That's the biggest problem. If you think of your sensor node operating at 3.3 volt, you may draw only 2 or 3 milliampere of current for normal operation. So you need only 6-7 milliwatt, okay, for your normal operation. But when it receives the data and when it sends the data, it takes around 40 to 50 milliampere of current. So you need around 150 to 170 milliwatt of power for transmission and receive. And that's the amount of power still you don't get from other source of energy. So still research is going on. We may have something in near future, but at the moment we are really stuck. So one group is telling that reduce the voltage level. So they work on differential voltage, plus minus 0.5 volt. But then the problem is sensor signal to noise ratio. So if your signal is very strong, you can go only 0.5 volt. But if your noise is too high, your sensor signal to noise ratio becomes a limitation. So that's why that proposal was not become very popular. So most of the system at the moment operates at 3.3 volt. So electronics is very important. We need to think of that design of electronics should be such that power consumption is less. But that power consumption, as I said, is not for the normal operation. It's for the receive and transmit. So unless we develop some kind of system, I mean basically energy efficient antenna, but what happens, you can reduce the antenna size or power level, then what happens, your range become less. So it's a problem, it's a trade-off. So another thing is that we have to think of that when we apply sensor node for remote monitoring, it should not harm the environment. Also, it should be such that it does not attract the animal. Okay, so you have to make something so that it's just hiding the color or something, so that animals will not get attracted. And so there are many incidents happen, sensor used for monitoring something, and then after a few months, it's not there. In New Zealand, one project was very funny. So they developed a sensor for monitoring the urine of the cow, location of the urine and how much urine. So they put a sensor in the cows. I don't want to tell here, but cows. But then they stick with the tail, and after some days, because human being, if we use wearable sensor, we feel uncomfortable, and animal also very similar. So after a few days, they did not find that sensor because the cow becomes so irritated putting the tails so many times, and sensor gone. And each one cost $250. So after a few months, the project stopped because you cannot go like that. So that's why there is a problem that how can you actually use the wearable sensor so that it's comfortable. Okay? So there are some issues. And so ethical issues also comes into picture. So sometimes you may not get ethical approval. So there may be animal groups, there may be some other groups. They will come and protest. Okay? You have to think of that. So in terms of the interfacing electronics, we have to be very clear when we connect the sensor to embedded controller, how do we match the speed, power, accuracy, resolution, so many things we need to consider. So those are the things we have to look into account, and also then what type of embedded processor we will do, whether it can give you the future expandability. So all these things we need to consider. And the most important thing is that you get a lot of data. Sometimes the similar data, two person can present in two different ways, isn't it? One can be completely confusing you, another can be giving you a very good picture. So how do you actually present the data? That's very, very important. So you need the target audience. So effective data presentation is a very good skill for the engineers, okay, in order to convince someone or to make angry. The communication protocol is another thing. We will look into that, one of the protocol IEEE 802, which is very popular for the wireless sensor network, especially for ZigBee. But there are many protocols. We need to also know some of them in order to make the wireless sensor network as well as IoT. As I said, IoT does not have a protocol at the moment. There are lots of research going on. IEEE has a task force. They are given the responsibility, but it's not a very simple thing. So they are working it for last 5 years, but still did not come up with something definite. So there are many issues for the data, storage of data and analysis of data, and of course the security and the integrity of the data. Sometimes we go for the graphical user interface to represent something very nicely, which is quite important, because if you think of that you do the design from engineering point of view, but at the end people who are using it, they are common people, and sometimes they get very much attracted with the design, you know. So those things we also, even though we do not like it, but we have to need to think of that. And installation and commissioning is also very important, especially if you have something you want to take the data not through the internet, but like sometime somebody has got some problem, heart problem or something, go to doctor gives some monitoring device, and that can continuously store the data for 24 hours or sometimes 72 hours, and then you go to the doctor again. But if you think of the environment monitoring, you have got some storage of data. You are not taking the data through internet. Then you have to send somebody to get the memory stick and replace the memory stick to get the data. So those type of situation is very, very complicated. So if you go for IoT, that problem is solved, because you do not need to store there locally. You can upload the data. So those are the things we need to think of. Replacement, repair issue. Replacement, one of the most important things, that whether you could go for interoperability. So if you follow a certain standard, then it can help the system. And has another thing. So remote sensing stations, you also need to look into quite a few things, and at the end, the cost. Cost is very important, because that dictates, and especially for distributed monitoring, the cost is hugely important thing, because you have got many systems. So yeah, so that was the last slide. Okay, so those are the issues we have. Actually, this 2 lecture gives you the big picture. Now we will go into the details of taking the sensor, and characterizations, other things, developing the electronics, making it mass sensor, wireless sensor network, and then IoT.